Okay, class, I'm going to give you some hints on problem 456 of assignment number 1, because a lot of students ask questions on the 3 questions here. Okay, so there's some hints here. Problem 4, the system is this. Okay, so given the input x of t, the corresponding output is produced is d over dt x of t minus t1, right? And I want you to check linearity and time invariant. So I'm going to just do the time invariant here to see what happens at here. Okay. Now, what I want you to do at here right now, you need to follow a certain kind of format. So we know that to check time invariance, we need to check if this equal to this. So we're gonna basically what we're gonna do is we're gonna get what's this first, and then what is this, right? Okay, so that's what you're gonna do here. Okay, you don't just simply write it the equal sign here and then start to write expression on both sides of equal sign and then make a conclusion in the end. So you write separately and see what do they produce. Okay, are they the same results? If they're the same results, they're time invariant. Okay, let's check the easy one, y of t minus t naught. Okay, so here's the concept I have always been emphasizing here. I mean, for example, okay, if y of t equal to t3, and I'm asking you what is the y of 3, right? So I think everybody knows that you're going to replace that t with 3 and then you calculate this one here. Okay, so in this particular case, we're not really dealing with a specific number at here. What we're dealing with is we're replacing the t with what? With t minus t naught. So basically, okay, if there's a t, then I'm going to replace that with t minus t naught. Okay, yeah. So in this particular case here, you don't replace this t here, so you still keep, because that's a derivative operation. Okay, it's an operator, so we don't replace this. So that's still the derivative here. So what we do is we are only going to replace this t here, okay, with t minus t naught, and that's basically what you get for y of t minus t naught. That's it. Okay. Now the trick here for the other side here, m bracket x of t minus t naught. I know a lot of you guys is able to write down the right expression, but what you did is basically just write down the answer here. Okay, so I'm gonna just what I'm gonna do is I'm gonna just simply put it into a little more detailed step at here. Okay, so I want to find out this, but what I'm gonna do is I am going to see, okay, let's just suppose that given input, okay, x1 of t, then output, okay, is y1 of t. Okay, because I do know what my system is, and my system, okay, so what happens is when you give the input is x1 of t, and here is x1 of t. Okay, so dx x1 t minus 1. Okay, so that's the output here, right? Okay, yeah. Now I'm gonna let x1 of t equal x t minus t naught. Okay, I'm gonna let this one equal to this. So the reason I'm doing is here, ultimately I'm checking this one here, right? So if I let x1 of t equal to this, basically this is becoming m bracket x1 x of t minus t naught. So this give me m x t minus t naught. Okay, yeah. Now what's at here is x1 of t minus 1 at here. Okay, x1 t minus 1. So if x1 of t equal to this, then, right, so it tells you what is x1 of t minus 1, right? So basically of this. So can we get from here to here? If I know what x1 of t minus 1 is, then I got the answer for this one here, right? Okay, so here's what I want you to do here. So x1 of t equal to this, and compared to x1 of t minus 1, so the difference here is this t is replaced with t minus 1. Then on the right side here, x of t minus t naught, then what you do is you're going to only simply replace this t here with t minus 1. So basically what it tells you is x1 of t minus 1 basically equal to x of t minus 1 minus t naught. Okay? Yeah. Now if you're still having trouble understanding this one here, let me give you this particular example here. Let's suppose that x of t minus t naught, okay, equal to t minus t naught, right? That's okay. That's a function. That's a function of t minus t naught, right? You gotta be careful that if I see, oh, look, here's a t squared minus t naught, now that's not a function of t minus t naught, okay? Yeah. Okay, that's some sort of a particular example, t minus t naught, okay? So then, and according to my definition here is I'm letting x1 equal to x of t minus. So basically that means x1 of t here equal to t minus t naught. Okay, and then what we're doing is we're trying to find what is x1 t minus 1. Okay, apparently, right? I mean, what you do, you just simply replace this t with t minus 1. Okay, so that's why here x1 of t minus 1 equal to x of t minus 1 minus t naught. And that's essentially your left side at here. Okay, the left side of the time invariant equation. So then you compare the right side and the left side, which turned out to be the same. Okay, so then you can conclude that this is a time invariant system. Sorry, yes, this is time invariant system. Okay. So let's take a look at the number 5 question. So number 5 question is actually, you can do that in a similar way as we did in the number 4, okay? So this question here, my system is this. Okay, this equal to x of at. Okay. So let me see if I want to check the time invariant system, right? So let's do the same thing. You're still gonna need to check whether what this equal to, and you're still gonna need to check what this equal to. Okay. Now maybe still do the simple one here. What's y of t minus t naught? Simple. So t is changed to t minus t naught. Your original system output is x of at. Then that t over there has to be changed to t minus t naught. Okay, don't forget a bracket. Okay, so what about this term in here? Okay, follow the procedure for problem 4. I am going to, assuming that I have an input x1 of t, and x1 of t will produce y1 of t. Based on this given system, the corresponding output for x1 of t is x1 at. And I'm going to let x1 of t equal to x of t minus t naught. Okay? So, basically, that means m x1 of t will equal to m x of t minus t naught. We know that when your input is x1 of t, you produce x1 of at. Then just simply based on the expression in here, the change of t in x1 function, okay, which is at now, will result in this t being changed to at. So that's at minus at naught. Then now you know the corresponding output corresponding to x of t minus t naught is this one here. Okay, so comparing both sides here, it's definitely not the same, and that's a time varying system. Okay, number 6. Well, number 6 is a little bit scary or ugly. That's because it's a piecewise function. Okay, so what it says is this. However, you shouldn't take it as a different any different. Okay, it's still a system. It's still a system which with the input of x it produces this output here. Okay, now we are still going to follow the same process, you know, the same process that you did for any one of the questions when you're checking linearity or time invariant or time invariant, right? Okay, now I think I'm going to skip the time varying invariant, but I'm going to show you here is the idea here. Okay, when you write, let's say for example, I'm going to check time varying invariant, and you still want to check these two quantity here. You still want to check these two quantity. Okay, now for the first expression, the change of t here is to change to t minus t naught. Now when you write, you still have to write the whole thing because that's the whole function output here. And the first one is 0 when t less than 0, so you don't change anything here. It's still 0. However, this t at here, okay, this t here is not going to be stay as same t anymore because you change your t from t to t minus t naught. So this actually should be changed to t minus t naught. Okay, so then the second expression here, and you know what to do. You change that t to t minus t naught, and you change this t to t minus t naught, and that's t minus t naught greater than 0. Okay, yeah. Let me illustrate this idea here a little bit here. Okay, so you already know that from y of t to y of t minus t naught is that's basically a delay of amount of t naught or shifting to the right by amount of t naught. So let's suppose, okay, suppose y of t, okay, it is a sort of a step function as we later here will learn. Okay, so this is a function here basically that equal to 0 when t is less than 0, but 1 when t is greater than 0. Okay, yeah. Now if I shift this one to the right by 1, okay, so then you have a graph like this. Now if I rewrite this graph in terms of the mathematical expression, that means 0 when what? T minus 1 less than 0, which is basically when t is less than 1. And that's 1 when t is greater than 1. You see that? That's where this t has to, that's what is t. This t here has to be changed to t minus t naught here. Okay? Yeah. And I'm pretty sure that you can check this one out. Okay, and you can check this one, right? M of x of t is changed to x of t minus t naught, so basically 0. So you are not changing t, you're only changing the input from x to x of t naught. So now this time, this t at here, okay, this t here is not going to be changed. That's still this one here. But this is t, x of t is changed to this. And this one is changed to this. Okay? There we go. Alright. So then you compare the both sides here. They are not the same. Okay? Because the t value, the range is different. Okay? So this time in time varying system. Okay? So the point here is, okay, don't be scared by this ugly log or the complex log. It's still a system. It's still the same function you're dealing with. It's just two parts here, but you deal with the same way as you have dealt with other questions. Okay, so that essentially are maybe the most difficult question for this first assignment. So take a look at it. Okay, I'll practice that linearity checking for this part of question here. All right, thank you.